A year ago, AI agents suggested. Now they do. They hold a real terminal, and there is almost nothing between them and the kernel. Claude Code, Cursor, OpenClaw. They stopped suggesting snippets and started running commands, installing packages, editing files, opening connections, touching production. And it is no longer one agent on one laptop. It is fleets, dozens, hundreds, on Kubernetes, each with a shell on a real host. That freedom is the whole point. An agent that cannot reach the servers and the data cannot do the work. But freedom on a real machine is a new attack surface. An agent can be talked into the wrong action, a poison tool, a prompt injection, a malicious dependency. And when it is, the attacker inherits its shell and its privileges on a real box. Look at where the guardrails actually are. At the prompt and the tool layer, there is a mature control that decides what the agent may be asked. That part is guarded. But below it, once the agent has a shell, there is almost nothing. Whatever executes on that host executes with the agent's hands on the keyboard. That gap between the agent and the kernel is the one we close. You already pay for security tooling. None of it was built for this, and the reasons are structural, not a setting you can change. Detection-only EDR reacts after the fact. Against a fleet moving at machine speed, the binary has already run before the ticket is triaged. Cloud EDR ships your data, and often your incidents, off the box to someone else's cloud. User space hooks leave exactly where a hijacked agent steps over them, and prompt guards stop at the tool layer. They cannot enforce what the process actually executes once a command gets through. 4 good products. All of them sit above the one line where the damage becomes real. So we do the opposite of the reflex. The reflex is to lock the agent down, sandbox it, take away its tools. But an agent that cannot touch the repositories, the servers, and the data cannot do the job. Restriction is not safety. It is a different way of failing. InnerWarden leaves the agent powerful and makes the dangerous actions stop being possible. Detection watches for bad behavior and reacts after it happens. We invert it into pre-authorization. The agent, or an attacker who hijacked it, can only run binaries cleared in advance and only resolve domains cleared in advance. Default deny enforced inside the Linux kernel, below anything a user space agent can bypass. Detection reacts after the fact. Pre-authorization decides before anything runs. Underneath, it is small. 2 Rust daemons and a command line tool. The kernel sees the truth. The sensor collects it. 32 collectors, 82 detectors, feeding a knowledge graph and 69 correlation rules. And the decision is made on the box in about 60 milliseconds. Firmware, hypervisor, kernel, sensor, agent, decision. One coordinated platform, from kernel truth to a local response. Block, kill, or gate. No cloud control plane. Nothing to phone home to. Most AI security needs a cloud round trip. Telemetry up, verdict back. InnerWarden makes the routine call on the host. Every incident is triaged in about 60 milliseconds by a pure Rust model running in process. No network call, no incident data leaving the box. And the claim is precise. The model is not trying to out-detect anyone. It is a compression of expert triage judgment. A teacher, fine-tuned on 2,400 real incidents, distilled into a small student at 1/10 the latency, with 99.6% agreement. An external model stays optional. Teach a big model offline. Ship its judgment as a small, fast one to every host. Pre-authorization is the moat, and we do not demo it on a slide. On a running Azure host, we armed the execution gate in observe mode, scoped to a single agent, rehearsed it to a clean zero-deny result, then emergency disarmed it. The live services were untouched, the box never bricked. The reasonable fear is that kernel enforcement bricks the machine. We engineered that out. Every gate follows one disciplined path. Observe, rehearse, enforce. Never a blind flip. Observe watches and blocks nothing. Rehearse replays your real workload and lists anything a flip would deny. One production host surfaced 18 legitimate paths a blind flip would have broken. Enforce is scoped to one agent, never host-wide unless you choose it. And disarming is always one command away. Install is not protection. Arming is. The fair question about anything that runs with root is, why trust it? Start with our own supply chain. The thing a serious buyer audits hardest. Every release binary is signed. The checksums are signed with published provenance. The installer verifies and fails closed. A tampered or unsigned binary aborts the install. Then, the runtime is yours. The sensor and the decision run locally. Only a redacted incident stream with the payload stripped is aggregated, and only to a coordinator you host. Nothing about a routine decision is sent to a third party. You can run it air-gapped, and we hold the defender to its own standard. A watchdog integrity verifies InnerWarden's own binaries and detects any attempt to disable it. It is brick safe and recoverable. You own the runtime, the telemetry, and the decision. You do not have to take our word for the bar. The vendor you already trust wrote it down. Anthropic published the security framework for deploying AI agents. It describes 2 layers: the agent-side controls that Claude Code ships, and the host enforcement and defensive operations underneath. InnerWarden is that layer. Access control, advanced. Kernel pre-authorization, observability, enterprise to advanced. Hash chain audit and real-time streaming. Behavioral monitoring, advanced. On-device learning, defensive operations, near 1-to-1. Its headline metric is blunt. Before anything else, instrument coverage and dwell time. Every incident triaged, nothing dropped. Detection to disposition in milliseconds reported per tenant on your own Grafana. So start where the risk is 0. Land on observability, day 1. See every agent, every incident, attributed to the tenant, the pod, and the agent that caused it, on your box, with nothing leaving your environment. Then expand on enforcement, 1 agent at a time, with disarm always a command away. The core is free and source available. Active defense, the armed gates, and the anti-tamper watchdog is $600 per agent per year. You pay only for the agents you actually arm. Earn trust free. Charge for the moat. InnerWarden. The guardrail belongs below the agent.